Files are an extremely important part of any programming language. File IO stands for input output. Here we'll understand how to create files in Python and how to manipulate files and directories and things like that. Files are basically a permanent way to store data on your hard disk or non-volatile memory like your solid state disk or hard disk. What happens is any data that you store in your memory or RAM is volatile, which means as soon as the computer is turned off, all the data goes off. So if you want to store any data for a longer period of time or forever, basically, you have to store it in your hard disk, right? This is just the way you create files in your hard disk. And to do that, we have to use file operations. To do that programmatically, we have to use file operations, right? So files typically have three broad operations: opening a file, performing an operation like read or write, and then closing a file. Now let's look at how the basic operation of opening a file looks like, right? Open is an inbuilt function and it is very straightforward. So you just say f equals to open example.txt. This opens a new file in the current directory, whatever directory I am in. For example, here, let me just change to my directory structure here. This is the directory that I am in, and here, anyway, we'll see how example.txt. In this directory, where I have my IPython notebook, in this directory, this file will be created. Okay, let's see the example anyway. I'll keep showing you the folder structure as and when needed. Now, a file can be opened in different modes. Let me explain what modes are. Okay, so you can give, for example, here, you can give modes like this, R. So you can say f equals to open example.txt with the second argument, which is R. Now let's see what that R means. R basically means that you open the file for reading. And if you do not give any second argument, the default argument is read mode, right? W stands for writing. What happens is it creates a new file if a file doesn't exist, right? If a file already exists, it deletes that file or it removes or truncates everything in the file and creates a new empty file for you. X basically means for exclusive creation. What does exclusive creation mean? If a file already exists, this operation will give you an error. If the file doesn't exist, then it will create a file for you, right? Similarly, A is for appending. What does appending mean? Appending means that if you have a file like this where you already have some text, right? Appending means adding to this text, adding new content at the end of the file. So that's what appending means. Appending means it opens a file without truncating or without deleting the existing contents. Similarly, there are broadly two modes when you're creating a file. One is called the text mode. Text mode is something where you actually store text in a file, like A, B, C, D, etc., etc. There's something called a binary mode where, so if you open a text file, in any text viewer, you can see the contents. For a binary mode, it's actually stored internally in a different format. So if you open it, you'll see gibberish. You'll see some random stuff here if you open it with a text viewer. So if you want to store text, the default mode anyway is text, right? You can store it in binary mode, especially if you're storing things like, if you're storing some matrix, if you're storing a matrix of data, or if you're storing lists of data, right? Or if you're storing some special variables about which are stored in here. So binary mode is used in scientific computation a lot, but text mode is also extensively used. Okay, so the default is text mode, right? You can also use it with plus, which means open for updating, which means reading and writing both. So these are all the modes in which you can open a file. Now let's see some code that makes life simpler for us, right? So here I'm opening a file. If I just say this, what it does is the default is this is equivalent to this, right? Because the default mode is R. Right? Similarly, I can open another file called test.txt in write mode. Now, since the default mode is text mode, how is the text encoded? How is the text stored internally? What is the format? There are multiple formats. There are formats like UTF-8, and there are many formats in which text can be stored, like ASCII, right, etc., etc. Okay, there is also something called as Unicode. Okay, text can be stored in multiple formats. And the way text is stored is dependent on your operating system. Windows chooses one format, Linux could choose other format, Mac could choose another format. It is very operating system dependent. But look at it this way, right? Python, to create files, has to talk to your operating system. And it's the operating system which actually manipulates and creates files. So Python talks to your operating system to do all your file operations, because it's the operating system which controls your files or hard disk and things like that. So Python doesn't directly talk to your file system. File system is the part is actually files are controlled within using operating system by a submodule in operating system called file system management. Okay, so that's why whether how the data is stored internally is very operating system specific. Windows could choose one format, Linux could choose another format, and things like that. Okay, having said that, how do you close a file? You've opened a file here and you can simply close the file. See, when you open a file, the file handler, so F here is called a file handler or a file pointer sometimes. Now when you say f.close, what happens is whatever data has to be stored in the file, whatever operations are still to be performed, it will perform all of them and close it. Let me take you a little details of how file storage actually happens, right? So suppose this is your Python, okay, this is your operating system and this is your RAM. Okay, let's assume this is your RAM and this is your hard disk. Okay, now in Python, when you're writing data to a file, let's assume I write A, B, C, D, E, F to a file. It actually first goes into the RAM before it goes and stores before it gets stored in the hard disk. You don't have a direct shortcut to the hard disk. So if you don't close a file properly, what happens is once you've finished your operations, if you don't close a file, all of this data could get stuck in the RAM, which is volatile. This is volatile, which means as soon as your computer power is turned off, all this data will go away, right? So if you do not perform the close operation, you are not guaranteed that all the data that you have, which is temporarily stored in RAM before it gets stored in the hard disk, could go away, right? So you should always close a file once the operations you intended to do are done with. Of course, you can do it this way. There is an other more cleaner way of closing a file using something called as try catch finally blocks. This whole thing is called exception handling. For those of you who have seen exception handling in other languages, this seems obvious. For those of you who have not seen it, we have a section called exception handling where you'll understand what does try mean, what does finally mean, what does catch mean, and things like that. For now, just remember, just keep at the back of your mind that this is a more cleaner and safer way to store your files. I'll explain you what these try finally are in the exception handling section. Okay, so this is a much more safer and much more foolproof way of actually opening your file and closing your file. Okay, this is a good programming habit in general. Okay, having said that, you can also open a file with an encoding of your choice. You can say encoding equals to. Okay, if you want to open a file with UTF-8 on Windows, you can choose the encoding format you want using the function, using the argument encoding. Okay, you can find more examples online, obviously. Just see how to encode a file in UTF or ASCII or Unicode. It's straight available for you. Now let's see how to write to a file. Okay, so to write to a file, you need to use write W or append or exclusive creation modes. So let's create a file called test.txt. Okay, so when we run this code, what happens now is interesting. What is happening now is I'm opening a file called test.txt in write mode, and I'm saying f.write. Whatever I write here goes into the file, and I'm closing the file here. Okay, so if test.txt did not exist earlier, it will now create it and it will put these two lines of text in it. If it existed before we started this, then what would happen is that this test.txt is overwritten now if it already exists. Now these two new lines will be added to the test.txt. Okay, this is how you write content. Using f.write, it's literally so trivially simple, frankly speaking. Now let's see how to, so now what we have a file with these two lines. This is the first line, contains two lines. These two lines of text we have in a file called test.txt. Now we'll see how to read this file in a bunch of reading related operations. Okay, so what am I doing now? I'm actually reading the same file. I'm saying open test.txt_r, right? So let's do a simple thing here. Now let's go to our folder and let's see. Okay. Let's continue here. I think that's a better thing to do. Okay, this way things become easier. So if I say test.txt in read mode, right? That's what I'm doing right now. So what happens here is I'm opening the same file. See, I have a file here which with these two lines of content. Now I'll go here and I'll say open test.txt and f.read. Okay, when you say f.read, it literally prints the whole content. Here \n means the new line. New line basically means put it in two lines, but this is just printing it as a string, which is perfectly okay. Now comes the interesting part. Instead of printing this whole thing, if you want to only read subsections of a file, see, this is a small file. Imagine if I have a huge file. Okay, I want to read maybe line by line, or maybe I want to read only the first few characters and things like that. There are a bunch of very interesting operations on files that we'll learn right now. So I could say f.open test.txt in read mode. So it will open this. And when I say f.read4, so as soon as I open, what happens is there is something called a file pointer or a cursor, okay, which is here. As soon as I open, it will be at the start. When I say f.read4, it means read first 4 characters. So it reads the first character, second character, third character, fourth character, and the file cursor moves here, or the file pointer moves here, or the cursor moves here. So it is print this. Now, if I say f.read10, now my file cursor is already here, right? So it will read 10 characters from this current location, from the current cursor location. This is important. Instead of that, if I want to read all the 10 letters, see, that's what you see here, right? When I said f.read the first time, it read the first 4 characters, and my file cursor came here. Now, next time when I say f.read 10, now it reads the 10 next characters from the current cursor location. That's why you get your output here, which is not, this doesn't mean the first 10 characters. It means the 10 characters from the current cursor location. This is very important. Okay. Now I have a function called tell. Now I've read 14 characters roughly. So f.tell will tell me what is my current cursor location, which is 14. Now if I want to go to the starting now, if I want my cursor location, see where is my cursor location at the end of these two reads? My cursor location is here at the 14th location. Now if I want to move my cursor back to here, what do? There is a function called seek that I'll use. If I say fseek 0, it will bring the file cursor to position 0. Now if I say f.read and print that, it will read the whole thing. Okay, very interesting. This way, if I have a large file, imagine if I have a large file with thousands and thousands and thousands of characters, I can go to exactly where I want and I can pick exactly what section of text I want using these read and seek and print commands. Very, very simple stuff, nothing very fancy here. And of course, tell is very useful. Okay, now let's look at different ways of doing the same thing. Okay, suppose if I want to print an entire file, I can just say print f.read. It will print the whole file. Okay, now if I want to read a file line by line, I can say f.seek 0. Now it goes to the starting. Now I can say for line in f, print line. So what it does now is it looks through each of the it reads through file sequentially till the time it finds the \n, because \n means new line, right? So wherever it finds \n, it will return that in line and I can print it. Okay, very simple and elegant way again. Now there is another way, or there is an alternative way called read line function. What it does is this. Here again, I'm reopening my test.txt file and I'm saying f.readline. So what's happening with f.readline now? F.readline basically reads the first line. And now the cursor is at the end of the first line. When I call f.readline the second time, it will read the second line because my cursor is at the end of the first line, right? So f.readline is basically looking for the \n. It will read up to \n, but the cursor will stay there. Okay. Similarly, there is a related function called read lines. This is again very useful. What read lines does is it reads all the lines till the end of the file is reached, and it will give each of your lines as elements in a list. So it literally returns you a list of each of your lines. Okay. Now, since you have learned how to create a file, how to read a file, how to write a file, how to close a file, let's learn how to rename and delete files in Python. Okay, so all renaming everything is available in a function called OS. Import OS. This is the module. This is the module in which we have all the key operating system related functions. Okay. Now I can say os.rename test.txt as sample.txt. So I'm simply renaming this file test.txt to sample.txt. Now again, let's see what happens when I say f equals to open sample.txt, because I've renamed it, right? And when I say read line, I get what I expect. Now I can delete it by simply saying os.remove sample.txt. Right? Very simple. OS is the module in which all these rename, remove functions exist. Now after I have removed or after I've deleted my sample.txt, if I try to read it, if I try to open it, what happens? As soon as I try to open it, it says no such file or directory sample.txt. Okay, I just wanted to show you an example of what type of error. This type of error is called file not found error. Right? Since now we have learned how to rename and delete files, how about folders, right? Or subdirectories? Now let's understand a bunch of very interesting commands. Okay, so let's look at it this way. Again, OS is the key module which helps us with all of that. Now when I say os.getCwd, CWD stands for current, it's already written here, it stands for current working directory. When you say get CWD, which stands for current working directory, it tells me what directory I am on. So right now I'm in this directory right now where I'm creating online videos for Python. Okay, so this is the directory that I am in right now. Now having learned this, how do I change my directory? If I want to change to just my home folder, again, by the way, I'm on a Mac system. I'm on a Mac. This path could change if you're on Windows or on Linux. Okay, so this type of syntax is typically very common in Mac and Linux systems. So just you may not get the same result. Again, here you might, if you're on Windows, you might have to say C / something something if you're on Windows. Okay, so anyway, you know how these folders are named in general. So here I'm on a Linux box, I'm in a Macintosh or an Apple Mac box or laptop, and hence you'll see syntax being slightly different here for the file names. It is operating system dependent because, as I told you, Python talks to the operating system for all file operations. Okay, now I know that my current directory is. Now if I want to change my directory, it's very, very simple. I just say chdir, which means change directory, to users Verma. This is called a home directory in Linux or Mac. This is where I'm a user Verma in which all of my data is stored. Right? Now I can say, now if I say what is my get current working directory, it says user Verma. Users Verma. Okay. Now how do I list directories and files? Right? So I can say os.listdir, which means list the directory. And which directory I want? I want the current working directory, which is my home folder. Right? In this folder, now these are all the files that I have. These are all the files and subdirectories I have in my folder, the bunch of them. Okay. Now let's see what happens if you want to create a new directory altogether. It's very simple. You can create a new directory by saying os.mkdir, which means make directory. You can read it as make directory. Very, very simple command here. Right? And if you want to remove a directory or if you want to delete a directory, that's also very, very straightforward. You just have to say rmdir, which means remove directory. But there is one catch. So since I've just created my test directory, it is empty, right? Empty directories can be removed using rmdir. If I want to remove a non-empty directory, I can't do it using rmdir. I'll show you an example. Okay. So rmdir is useful to remove an empty directory or a directory which doesn't have any subdirectories or files. Now to remove a directory which has files or subdirectories, how do we do it? Let's see an example. Okay, so here what am I doing? I'm creating a directory called test and I'm changing my directory to test. Okay, so dot basically in Linux or Mac means the current directory. So this means current directory. Okay, double dot means the parent directory of my current directory. This is true. This is double dot. Okay, this is true in any Unix based system or a Mac. Even a Mac is a Unix based system. This is, I don't know if this exactly holds true in a Windows system. Just try it. Okay, having learned this, now what am I doing here? I'm creating a test directory and I'm changing my directory to that. Here I'm opening a file called testfile.txt in which I'm printing some content. Okay, and now I'm changing back to my parent directory. So I'm on /users Varma, right? Here I created a test. Within test, I created a test file, right? Now what am I doing here? I'm here right now, right? So currently I'm here. When I say OS changed it .. now my current directory becomes users Varma because I'm going to the parent directory of this. Now here now I'm trying to say os.remove their test. Okay. Now remember, test is non-empty because it has a file called testfile.txt. It's a non-empty directory. Now what happens when I try to use rmdir to remove a non-empty directory? It simply says directory not empty when OS error. Now how do you remove a non-empty directory? There is a way to do it. You have to import shutil. These are basically shell utils. Okay. Add something. So you have to import something called as shutil. Now in shutil, there is a function called rmtree, which means remove the whole tree of, because these are internally stored as trees. Or okay, you have a directory 1, right, which has a directory 2, right, which has a directory 3, which could have a file 1, etc. This is thought of as a tree. So what this means is remove the whole tree corresponding to this directory. And you can say shutil.rmtree test, and this is used to remove a non-empty directory. Once I've removed a non-empty directory, if I just say what is my current working directory, I'm back to users Varma. Okay, so these functions that we've learned in this video helped us learn how to create a file, how to read a file, write a file, rename a file, delete a file, how to understand which folder you're in, create folders, delete folders, remove all the contents in a folder, and things like that. It's a very, very useful bunch of operations, especially file operations. We will use them extensively.